This video lecture is meant to cover the information found in Chapter 10 on moles, molar mass, and molar conversions. You will need a calculator and a periodic table in order to really follow through with this lecture. So if you don't have those things, please take a moment to collect those things and then come on back to the video. First question on this worksheet, where we're getting started with the concept of molar conversions, is 1 mole of methane weighs how much? Well, methane has the formula CH4, and if you go to the periodic table, carbon has a molar mass of 12.0 grams per mole, and each hydrogen weighs 1.0, but there's 4 of them, so that's 4.0, and so adding all that up, it turns out that 1 mole of methane will weigh 16.0 grams. The next question says how many molecules will be in 1 mole of methane? Well, this question doesn't matter that it's methane. 1 mole of any substance will, of course, have 6.02 times 10 to the 23 particles. So now the question is, well, what if you don't have 1 mole of methane? What if you have half of a mole of methane? How much will it weigh? Well, 1 mole of methane weighed 16 grams, so half of a mole will weigh 8 grams. Question number 4 says, how many molecules will there be in half of a mole of methane? So how many molecules? Well, 1 mole of methane had 6.02 times 10 to the 23 molecules, so half of a mole will have 3.01 times 10 to the 23 molecules. Question number 5. How much will 2.0 moles of methane weigh? Well, we know that 1 mole weighed 16 grams, so 2 moles will be double that, 32.0 grams. How many molecules will there be in 2.0 moles of methane? Well, 1 mole had 6.02 times 10 to the 23rd, so if you double that number, you get 12.04 times 10 to the 23 molecules, which is 1.204 times 10 to the 24 if we adjust that number to proper scientific notation. Question number 7 says 1 mole of sodium hydroxide, NaOH, weighs how much? So consulting your periodic table, you will find that sodium weighs 23.0 to the nearest tenth, 1 oxygen weighs 16.0, and 1 hydrogen weighs 1.0. So adding all that up, you get 40.0 grams. So 1 mole of sodium hydroxide will weigh 40.0 grams. How many formula units will there be in 1 mole of sodium hydroxide? Well, 1 mole will have 6.02 times 10 to the 23 formula units. It's called a formula unit because NaOH is an ionic compound, and the smallest particle of an ionic compound is a formula unit. How much will 0.25 moles of sodium hydroxide weigh? Okay. 0.25 is the same thing as a quarter. So a quarter, if 1 mole weighs 40 grams, then a quarter of a mole of sodium will weigh a quarter of 40 grams, which is of course 10.0 grams. Number 10, how many formula units will there be in a quarter mole of sodium hydroxide? Well, a quarter of 6.02 times 10 to the 23 will yield your answer. So a quarter of 6.02 ends up being 1.50 times 10 to the 23 formula units. Number 11. How many moles are in 1.20 times 10 to the 24th formula units of sodium hydroxide? So now I'm asking you this question sort of in the reverse. You might recognize this number 1.20 times 10 to the 24th as being double Avogadro's number. So therefore this is 2 moles. Number 12, how many formula units are in 20 grams of sodium hydroxide? Okay, and here's where this starts to get a little more complex. 20 grams of sodium hydroxide, you might recognize 20 grams is half of 40, right? 20 grams is half of 40, so this is 0.5 of a mole. Because 20 divided by 40 is half of a mole. But the question is not asking how many moles, it's asking how many formula units. Well, you know that 1 mole has 6.02 times 10 to the 23. Now we have half of a mole, so that's going to work out to 3.01 times 10 to the 23 formula units. So you can see these problems can start to get a little more complex, and there's going to come a time, right about now, when we're going to have to learn how to set up these problems in a little bit more of a formal manner. This has been mental math so far, but what we need to do now is to set up, return to our dimensional analysis techniques in order to be able to solve problems that are trickier, and you're going to need more than just mental math. Okay, so here's where we're going to take a look here at your lecture notes. And you can see here that it says that we're going to need to convert between moles and particles. And to do that, we're going to need a conversion factor based on the equivalent statement of 1 mole is equal to 6.02 times 10 to the 23 particles. And you can use that equivalent statement as a fraction, and that fraction can be in either orientation. So you can have 1 mole over 6.02 times 10 to the 23, or 6.02 times 10 to the 23 over 1 mole. Okay, and we should have the word particles here, so we have a unit there. And I'm going to use the generic term of particles here because we don't know what kind of substance we're working with. But a conversion fraction like these, you can use them in either direction, whichever direction you'll need to in the particular problems you're going to see, because these are equivalents, and of course because they're equal, 6.02 times 10 to the 23 is equal to 1 mole. Either way you have this fraction, it's equal to the quantity of 1. Sometimes you're going to have to convert between moles and mass, and the conversion factor that you're going to have to use here is 1 mole is equal to the molar mass, which you'll have to get from the periodic table, and it is dependent on the substance in the question. So you'll set up a fraction, and the fraction can be either direction. It can be 1 mole over the molar mass, or molar mass over 1 mole, depending on which problem you need to do, or whichever problem is given to you. If you have to convert between particles and mass, this is going to be a 2-step problem, and you're going to need to use 2 conversion fractions, one of each of the types that we just talked about. Okay, and so you'll see here some calculator review tips before we get started on these problems. You should use the times 10 to the n button to put in your exponent for your scientific notation numbers. You should put parentheses around all numbers that are in scientific notation, or else you will have order of operations difficulties. And you'll need to use the right arrow button to move the cursor out of the exponent field if you are using the math print mode. I recommend that you use the classic mode, and to do this you can go to the mode button on your calculator and make sure that you're on the classic mode. You can avoid that problem in the 3rd bullet point there. You see here, this is a visual representation of the strategy that you might use to solve problems. There are 3 things that you can convert moles from. We're only going to discuss 2 for now. You can convert moles. You can convert moles to particles, and to do that you need to use a conversion fraction using 1 mole is equal to 6.02 times 10 to the 23 particles. Or you can convert between moles and grams using the conversion fraction 1 mole is equal to the molar mass from the periodic table. But if you need to go from grams to particles or particles to grams, that's where you're going to need two conversion fractions, one using the molar mass and the other one using Avogadro's number. So this is kind of a handy visual representation to help you keep track of where you are in your problems. So let's try a few together so you'll understand what I'm talking about. Converting 5.0 grams of hydrogen to moles. All right, so starting with the number given to you, 5.0 grams, what we want to do here is convert that to moles. So setting up a conversion fraction, I would recommend you start by putting a multiplication sign and a fraction bar. The first thing you're going to want to do is put the unit of grams in the bottom so that it'll cancel with the unit of grams that you started with. And you can go from grams directly to moles. And before I go on with this problem, I'm going to go back and show you what I mean on our map here. We started with a number that was in grams. We're trying to go to moles. So all I need is the 1 mole is equal to the molar mass from the periodic table fraction. So this is just a single step problem, a single fraction problem. And when you're doing these conversion fractions, you're always going to have the number 1 next to the mole. And then the number down here is going to come from the periodic table. So hydrogen, if you add up the molar mass from hydrogen in the periodic table, it is 2.0. And we're going to round those molar masses to the nearest tenth. So this becomes simply 5 divided by 2, which is 2.5. Okay, grams cancel, leaving us with a unit of moles. Alright, so in problem number 2, we're going to be converting 636 moles of water to grams. So again, in these problems, always start with the number that you are given. In this case, it's 636 moles. And I'm going to step us back to the mole map right here. Here we're starting in moles, and now we're trying to get to grams. So again, we're going to have to use that molar mass conversion from the periodic table. So this is just going to be a single step problem. Going back to the problem, 636 moles, we're going to have a single conversion fraction. We're going to put the unit of moles in the denominator so it'll cancel with the moles that we were given. And we are going to put grams up in the numerator. Now the numbers that fill in here, you're always going to put 1 next to the mole because it's always 1 mole is equal to some mass. And so this is the molar mass from the periodic table. If you add up the molar mass of hydrogen and oxygen, it works out to 18.0 grams. So what we'll have here is moles will cancel, and you will end up with 636 times 18 in your calculator, which works out to 11,448 grams, but this is awkward because you have 3 sig figs to start with and you have 5 sig figs in your answer. So rounding this answer to 3 sig figs would be 114 or 11,400 grams. So that's the best answer rounded to the proper number of sig figs for that number. All right, problems number 3 and 4. Number 3, we're starting with a certain number of molecules and we're trying to convert it to moles. So if we take a look, I'm going to go back and take a look at our mole map here. And in this problem, let's get this erased so we can see what's going on here. In this problem, we are starting in molecules, which is a particle, and we're trying to convert it to moles. So that's just a single step problem, and you're going to have to use Avogadro's number to help you do it. So that's what that mole map is supposed to help you see how to do these problems. All right, so single step problem. Start with the number you're given, 7.8 times 10 to the 20 molecules. One step problem, so set up a single fraction. The unit of molecules will go in the denominator. We're trying to go to moles, so we'll put moles up top. You're always going to have 1 next to the mole. 1 mole is going to be equal to 6.02 times 10 to the 23 molecules. We'll see that molecules will cancel, and when you multiply 7.8 times 10 to the 20 divided by 6.02 times 10 to the 23, make sure you put parentheses around those scientific notation numbers, or else you will have order of operations problems and you'll get the wrong answer. But this works out to be, to the proper number of sig figs, 2 sig figs to start, so we should end up with 2 sig figs to end. You'll get 0.0013, and the unit there is moles. Number 4, we are starting with 548 moles, and we're trying to convert that to molecule. So it's really just the reverse conversion of what we just did. Starting with a number given, 548 moles. It's going to be a single step problem. I'm going to put moles in the denominator and molecules in the numerator. The equivalent statements are always 1 mole is equal to something. So 1 mole is equal to 6.02 times 10 to the 23. Moles will cancel, and you'll get in your calculator an answer that we're going to make sure it has 3 significant figures. Should work out to 3.30 times 10 to the 26 molecules. That's a 6. Problems 5 and 6 are a little bit more complex. They're going to be 2-step problems, and I know that because we're going from molecules to grams. So we have to do this in 2 steps. If you go back and look at your mole map, you can see that molecules and grams, the only way you can do those problems is you have to convert to moles first. So start with the number you're given, 9.6 times 10 to the 25 molecules. You'll set up your first conversion fraction. We'll put molecules in the denominator because that's what you're starting with and that's what you want to cancel out right away. You have to convert it to moles. So filling in the numbers here, you always have 1 mole is equal to something. And since it's molecules, it's 1 mole is equal to 6.02 times 10 to the 23 molecules. If we left the problem right here, molecules would cancel and your unit left over would be moles. But we don't want to go to moles, we want to go to grams. So set up a second conversion fraction. I'm going to put moles in the denominator so it'll cancel with the moles that's right there. And I'm going to put grams up top. Remember, it's always 1 mole is equal to something. So 1 mole is equal to the grams. From the periodic table, you got to add up the molar mass for NH3. It works out to 17.0 grams if you add it up correctly. Moles will cancel. Your final unit will be in grams. You should round your answer to have 2 significant figures. And the answer is, when it's rounded to the proper number of significant figures, should be 2,700 grams. Number 6, we're converting 0.025 grams to molecules. So again, this is going to be a 2-step problem. We're going to have to convert to the mole first. So again, you start with the number 0.025 grams. You set up your first conversion fraction. The number or the unit that goes into the denominator is the unit that you want to cancel that you started with. And like I said, you have to convert to the mole first, so that would be the conversion fraction units, moles over grams. Remember, it's always 1 mole is equal to some number. In this case, this is molar mass, so we have to look up and know that the molar mass of KCl is 74.6 to the nearest tenth. So 74.6 will go in the denominator. If we leave the problem like this, our final unit would be moles, which is not what we're trying to do. We're trying to get to molecules. So you set up a second fraction. We're going to put the unit of moles in the denominator, so it'll cancel, and the unit of molecules in the numerator. Remember, the numbers that go into these fractions, it's always 1 mole is equal to some number. In this case, 6.02 times 10 to the 23 molecules. Moles will cancel out with each other, so our final unit will be molecules. And we should round it to a total of 2 significant figures, because that's what we started with. And if this is done correctly in your calculator, 2.0 times 10 to the 20 And I just realized my mistake here. This is not molecules. You have it written as formula units, which is a better descriptor of this substance because it's ionic. So if you caught me already, good for you. And so this is 2.0 times 10 to the 20 formula units. 2 sig figs is 2.0 times 10 to the 20 is the entire answer. 2.0 times 10 to the 20. All right, when you return, the next thing that we're going to get to is more practice with these molar conversions. So we will see you in the classroom.